Now we are going to deal with the module 2, elastic properties. In this session we are going to deal with the basics. Now the topic is elasticity. Before going to start with elasticity, we look at some of the definitions. First, deforming force. Deforming force is a force that produces deformation. What is meant by deformation is change in the dimensions like length, volume and shape to the object. Next is a restoring force. Restoring force is force equal and opposite to that of a deforming force that comes into play, which tries to restore the body to its original state. On removal of deforming force, restoring force brings the body to the original state. That means here deforming force and restoring forces are opposite to each other. Deforming force changes the shape and restoring force brings back to the original state. Next is elasticity. Elasticity is a property of a materials by virtue of which they regain their original shape and size after the removal of the deforming force acting on them. That means the property of a materials by virtue of which they are coming back to the original shape and size after the removal of the deforming force is called as a elasticity. Next is plasticity. Plasticity or a plastic property is a property of a material by virtue of which they retain their deformed shape and size after the removal of the deforming force acting on them. Now, if you see at the plasticity and elasticity, plasticity means it is retaining. That means it is fixed. Once the body is being changed its shape, it remains in that shape only forever. Whereas elasticity means it is regaining, that is coming back to the original shape and size after the removal of the deforming force. Next we see the classification of materials. Materials are classified into two groups based on their elastic property. That means elastic materials and plastic materials. Elastic materials are the materials which regain their original state on removal of deforming force. Example, quartz, steel and rubber. Plastic materials are the materials which are not able to regain their original state on removal of deforming force. That is, they are retaining. That means whatever the shape they have got it is been fixed. It is, when there is a change in shape, it will be fixed. Whereas elastic properties means they come back to the original property. So this is the difference between elastic and plastic materials. Next, note, in general, no material is perfectly elastic or perfectly plastic. Next definition is load. Load is an external force acting on a body that produces a change in the dimensions of the body. What is load? Load is nothing but an external force acting on a body that produces change in the dimensions of the body. Stress. What is stress? Stress is a restoring force per unit area of cross section of a wire or a rod. Stress is defined as force per unit area of cross section, that is F by A. Units are Newton per meter square. Next, what are the types of stresses? There are three types of stresses. Longitudinal stress or the tensile stress. It is a stretching force acting per unit area of cross section of the solid along its length. Force is applied normally to the cross sectional area. Longitudinal stress produces changes in length only but not in the shape and volume. So longitudinal stress is when there is applied force, it is along the length. Dimensions are changed along the length. Longitudinal stress is a stretching force acting per unit area of cross section of a solid along its length. Now next is bulk or volume stress. It is a stress in which the body is subjected to equal normal forces on all the faces. Bulk means it is a stress in which the body is subjected to equal forces normally on all the faces. That is, bulk stress produces changes in the volume of a body but not a shape. So next is shear stress or the tangential stress. It is a force acting tangential per unit area of a body. Shear stress produces changes in the shape of the body but not in the volume. So here we have seen the three stresses. One is along the length is a longitudinal stress and one is next is bulk modulus. Bulk modulus, you can assume that a balloon is filled with the water and you press the balloon, the volume is being compressed. There is a change in the volume but not the shape. So what is happening, it is like a balloon filled with water. When it is pressed, what will happen, it will be compressed. So that type of a stress is called as a bulk stress, and the force which you are applying with your hand on the balloon will be normal to the surface on all the faces. That is a volume stress. Next is a shear stress. It is a force acting tangentially per unit area of a body. It is acting tangentially. Shear stress produces changes in the shape of the body but not in the volume. So these are the three types of stresses. Next we see with the strain. Strain is a ratio of change in dimensions of the material to the original dimension. Actually, strain is a ratio. It is a ratio of change in dimensions of a material to the original dimension. So it doesn't have any unit because numerator and denominator, it is a ratio. Both the units get cancelled, so nothing. That is a ratio, just a ratio. Change in the dimension to the original dimension. There are three types of strains. Longitudinal strain, that is a ratio of change in length to the original length, is called as a longitudinal strain. That is change in length by original length. That is delta L by L. Delta L is the change in length and capital L is the original length. Next is a volume strain. Volume strain is a ratio of change in volume to the original volume V. Volume strain is change in volume to the original volume, that is delta V by V, capital V. That is delta V is the change in the volume and V, capital V, is the original volume. This is a original volume. Next is a shearing strain. Is a ratio of lateral displacement between the two layers delta X to the perpendicular distance between the two layers, that is X. So shear strain is lateral displacement between two layers by perpendicular distance between the two layers, that is delta X by X. So these are the three types of strains. So we have seen the three types of stresses and the three types of strains. Now we will see what is the importance of this type of elastic materials in the field of engineering. See, these type of elasticity, right from your lower classes you have been studying all these types of modulus, what is Young's modulus, all those things. So we will see why exactly we are studying this importance of elastic materials. What on basis of elasticity, materials are been classified into two categories: elastic materials and plastic materials. Now what is the use of these plastic materials in the engineering field, we are going to see. The knowledge of elasticity is very important in engineering applications, which are described as below. By knowing the elastic properties of different materials such as a tensile strength, ductility, elastic limit, plasticity, stress or strain relationship, various moduli of elasticity, and how the above properties can be altered, etc., engineers can make a better choice of materials for their use in different branches of engineering. That means if we know the materials which are plastic and which are elastic, based on the type of a material and the purpose which we are doing it, based on the purpose we can have the material to be made up of that type of applications. See, here we have seen different materials. Tensile strength, how much a material can hold a wire, like a cranes. Ductility, elastic limit, plasticity, stress or strain relationship, all these things, once we know the type of a material and we know the characteristics of this metal or a material, that metal can be used in a better way for the applications. Next is, we can see the examples. Example, pure metals are very soft. Like if you see any gold bangle, if it is pure bangle, it will be soft. But if you mix some other metal to it, it becomes strong and it can be used for a better applications and the duration will be more. For example, pure metals are soft, hence they are not preferred in engineering applications. Whereas alloys are harder, they find wide applications in the engineering. Even iron, if you add some more material to it, it becomes more harder, like steel. So steel is nothing but an alloy. So when you add some material to it, it becomes strong, so which we can use for a better applications. Metallurgy deals with the use of materials or the metals for different applications of engineering fields. That means metallurgy deals with the types of metals which are used for various different applications of the engineering fields. So this is how the elastic materials or the properties are being utilized in the engineering fields. Thank you.